Hello everyone. I'm Rohit Verma. I'm a research associate at the Department of Computer Science and Technology at the University of Cambridge. Today I'll be talking about RACER, real-time automated complex event recognition in smart environments. So before I move ahead, let me talk about atomic and complex events. Atomic events are basically simple events which are detected using single sensors, while complex events are indicated when multiple such atomic events occur in a given span of time. For example, coffee pot event detected in the morning could be either employees arriving for the morning shift or maybe a group meeting which is occurring in a nearby meeting room. There are specific characteristics which could be identified to check what complex event is actually happening. For example, along with the coffee pot event, say motion sensors are being triggered near a particular office, then maybe it could indicate that along with the coffee pot and the corridor walk event, that a group meeting is happening in that particular office. Now, there are existing systems which perform complex event detection, but they have two specific limitations. First is that they do not consider the impact of sensors in the vicinity for atomic event detection. For example, in a particular room, if there are different sensors like temperature, humidity, CO2, etc., then they only consider for temperature related atomic event, they only consider that the temperature sensor. However, it's quite obvious to understand that in a maybe on a rainy day or maybe on a hot or humid day, the change in humidity sensor values would be correlated to the change in the temperature sensor values. On the other hand, these works also do not consider temporal characteristics, like, for example, the change in temperature sensor in summer would not be what it is basically in the winter. So, keeping these limitations in mind, we develop RACER, which is an end-to-end system which takes input data stream from different sensors and detects atomic events, and using those atomic events, detects if a complex event is occurred or not. It has three major building blocks. First is the feature extractor, which with the incoming sensor data, extracts the spatial temporal characteristics of the data, and then along with the raw sensor data values, and these spatial temporal characteristic values generates the input vector, which is fed into the atomic event detector. The atomic event detector then trains an ML model to detect atomic events based on the input vector that it is receiving. Once these multiple atomic events are detected, these are fed into the CEP layer, which has two submodules, the CEP rules and the CEP engine. The CEP rules are basically expert-generated complex event rules, which, along with the atomic events, are used by the CEP engine to detect if a particular complex event has occurred or not. We evaluated RACER over 5 buildings along with 185 sensors and observed that compared to the existing systems, RACER performs much well. And we also observed that the latency for the end-to-end computation is around 37.35 milliseconds, which for any real-time system, which is quite good for a real-time system. Thank you for attending my talk. I'll be happy to take any questions.